Guys, welcome to my channel. I'm leetcode, and today we have a pretty interesting topic. My last video, guys, we went over we were talking about the different type of graph, right? So today we'll be going over how to represent the graphs, right? So a lot of the terminology that I'll be using in this video, right, I've already covered in my last video, guys. So I would advise you guys to go watch that video and come back, and so this can make a lot more sense, right? So pretty much I'll show you guys how to represent the graphs, right? What I'm saying. So I'm gonna show you guys how to represent the undirected, directed, and also if I have time, I'll go over the weighted graph as well, right? So let's quickly step into it, okay? So pretty much we're gonna cover the undirected graph first, right? What I'm saying it's undirected. All right, I'm doing my pen down writing. Undirected, right? Apologize for the bad handwriting, guys. So I'm saying it's kind of hard to write, so yeah. So what I'm gonna do, guys, I'm gonna draw an example, right? 0, 1, 2, 3, right? So pretty much, guys, we're gonna pretty much represent that graph, right? And adjacency format, right? So so adjacency matrix, right, is pretty much a 2D matrix, guys. So a V by V, right? So pretty much for the rows, we're gonna have all the vertices listed out, right? And then for the columns, we're gonna have the vertices as well, right? I'm saying, so we could easily store the information at every cell, right? If two objects, if there exists an edge, right, a connection between the two objects. So I'm saying, so I'm gonna do an example real quick, guys. Don't worry, guys. So pretty much for the column, for the rows, right, I told you guys 1, 2, 3, and then for the columns, right, I told you guys the same thing, 0, 1, 2, and 3, right? So let me just draw real quick. So it's just very clear for you guys. It's my priority, guys. I'm saying. All right. So now, right, we could easily store that, right? So I told you guys it's undirected, right? So that means that we could go from 0 to 1, or from 1 to 0, right? So it's a bi-directional, guys. So I've already went over that in my other video in great detail. So I recommend you guys check that out. Okay. So yeah, guys, like I was saying that, right? So we need to show the connection, right? So pretty much, the rows, right? You know what I'm saying? You could think of it as we're going from, right? From this node to that node, right? So the columns are gonna be all gonna be to, and the rows are gonna be from, right? So to show, so initially everything's 0, right? You know what I'm saying? I'm gonna fill it with 0 after. So right now I'm showing them as empty, so it doesn't matter, right? So from, right? So we can go from 0 to 1, right? Right? Because that's what the edge is telling us, right? So since we can go from 0 to 1, right? So we can we're gonna put a 1, right? From 0 to 1, from 0, right? From 0 to 1, right? You know what I'm saying? So for the row, it's gonna be 0, and then the column is 1, right? So we put a 1 there. You know what I'm saying? Yeah, and just like that, we keep doing that, right? So make sure that also show that we can go from 1 to 0. You know what I'm saying? You can show that connection as well, right? So we do 1, which is this one, right? And then we do 0, right, guys? So you got to make sure you do that, right? So we put a 1 there, right? So we take care of the case, right? Of 1, guys. So we've took care of that edge, right? So we're good. We're Gucci on that, right? So what's the next thing that we're gonna do, guys? So we need to show we can go from 1 to 2 and 2 to 1, guys. We can go from 1 to 2 and from 2 to 1, and then from 1 to 2, guys. So we can go in either direction, right? So let's quickly fill it up. So we do 1, 2 that will be a 1, right? And then 2, 1 will be a 1 as well, right? To show that relationship, guys. So very, very important, right? And then we show this one for this one, right? So this one will be 2, 3, right? 2, 3, which is a 1, and then 3, 2, right? Which is a 1 as well, right? So pretty much we've showed the connection, guys. So everything else could be filled with 0, right? Just like that, right? Everything is 0, right? So we successfully showed that we can pretty much represent the graph in adjacency matrix, guys. So you see how easy it is, guys. What I'm saying, to show it like that, right? So you can see we are using a lot of space, right? You know what I'm saying? It's a V by V space, you know what I'm saying? So now let's talk about how do we represent it using adjacency list, guys. So pretty much, guys, you could think of it as an array of lists, guys. So right, and pretty much the size of that array, right, is going to be equal to the amount of vertices on the graph, right? You know what I'm saying. And so at every index, right, you know, they're pointing to their respective list. You know what I'm saying. So the list, right, for at every index, right, you know what I'm saying, represents the list of adjacent nodes to that vertex. So I'm saying, so for node 0, right, you know what I'm saying, it would point to pretty much 1, right, because 1 is the only adjacent node, you know what I'm saying, the only one, right? So that's the only one in that list, right? So for 1, right, yeah, for pretty much all of them, pretty much, right? Yeah, so for 0, 1, right? And then now for 1, right, we also need to show that relationship, right, which is 1 is pointing at 0 as an adjacent node, right? You know what I'm saying. All right, so we got 0, right? 1 is pointing at 0, right? 1 0 not pointing at nothing, right? And then now we need to show that that 1 is also pointing at 2, right? Because 2 also has a connection with 2, so it would point to, I'm saying, 2, guys. I'm saying we put a 2 in there because we have that connection from 1 to 2. I'm saying, and then 2 also has a connection, right, with 1. I'm saying, so we need to store that, right? Make sure that we don't lose reference to that, right? So after we do that, guys, you know, we 2, and after it, 2 is gonna be pointing at null. I'm saying, because those are the only 2 nodes that that 1's connected to, right, which is 0 and 2. I'm saying, so and then for the other one, guys, I'm saying for 2 is pointing at 3 as well, right? So now 3 is part of the list, right? So you need to add 3, right? And then yeah, then 3 is has a connection with 2, guys, which is very important, guys. Right? Yeah, and seems like we got everything covered, guys. So we were successfully able to, I'm saying, so we could see that we got 0, right? So 0 is 1, right? Cool. And then we got 1 to 2, all right? And we got 1 0 for 1, so that's checked. And then for 2 we got 1, we got for 2 we got 2 to 3, right? And we also got 2, we got 2 to 1, right? So we got that as well. So we take care of all that case. In 3 we can go for 2, right? So we have that represented, right? So we checked all of the boxes, guys. So again, we're gonna be covering the undirected graph, right? So the directed graph right now. So it's a little bit simple too, right? It's as simple as the other one, guys. So pretty much we're gonna draw the graph, right? So we draw the graph. Now it's directed, right? So I'm just 0, 1, 2, 3, right? And then we do the same thing. So I'm gonna start drawing out the matrix. So I'm saying, so pretty much we have 0, 1, 2, 3, 0, 1, 2, 3, and then yeah. So I don't know. That's what I'm trying to do. I'll just do. Should I get everything correct? So this one, yeah, so right now we know that the rows are from, right? And then this one's 2, right? The columns are 2, right? So the way we're gonna do it, right? So this one's directed, right? It's not bidirectional. So we can only go from one point to the other. I'm saying we can't go from the other to one point, what I'm saying. So for this edge, right, it says that we can only go from 0 to 1, right? What I'm saying, we can't go from 1 to 0. It's not the same thing, right? That's one of the differences with undirected. I'm saying very, very important that you guys know that. I'm saying I went to a lot of detail in that other video, so go watch that video. Okay, so right now we got the directed, right? So now we're gonna show the relationship, right? So from this graph, right, visual graph, we can see that we can go from 0 to 1, right? So we're gonna mark it with a 1. I'm saying to show that they are connected. I'm saying you can go from 0 to we have an edge for that, right? So okay, we can go from 1 to 2, right? Okay, from 1 to, okay, yeah, there's a 1, right? That's good. All right. So we can go from 2 to 3. You know what I'm saying 2 to 3, put a 1, right? So yeah, guys. So and then everything else. So there's no self loop. So 0 to 2. There's no connection from 0 to 2. So 0, 0, 3. Nope. Yeah, 1, 0. Nope. We can't go from 1, 0, right? 1, 1. Nope. 1, 3. Nope. Right. So I think that was 0, guys. You know what I'm saying everything else is 0. So and 3 has no one it can get to. So that's the adjacency matrix way of doing the directed one, right? You know what I'm saying? Yeah, guys. So now we're gonna go over the adjacency list, guys. So very similar to the other one, right? So it's kind of the same logic, pretty much. 3, right? So pointing to. So we can go from 0 to 1, right? So since we go from 0 to 1, we're gonna put it in there. So we're gonna have a 1, right? And then that's it. That's the only person you can get to, right? Let's say from 1, we can go to 2, right? 2. All right, and then points to null, right? And then 3 or 2, I mean, can go to 3, right? Pointing at 3 now. All right, we got that. All right, then 3 as null. You know what I'm saying? Because 3 can't get anywhere, so null, right? So yeah, man, you see how easy it is right now to represent the different graph, right? So we could the way that I do it, right? You see that we can go from 0 to 1, right? But we don't have 1, so 0 is not part of the list for 1, right? You know what I'm saying? It's not part of it, guys. I'm saying the other one, directed graph, right? It was part of it. You know what I'm saying, but for this one, it's not part of it. It's directed, guys. You know what I'm saying? So this is how we show that we can go from 0 to 1, but we can't go from 1 to 0. You know what I'm saying? So very, very key thing that you guys make sure that you guys understand, guys. What I'm saying, very, very important. Yeah. So right now, let's talk about the weighted graph, right? The weighted graph, guys, is gonna be very, very good. All right, so this one's gonna be simple as well, right? Pretty much, guys, let me just draw a quick one real quick so you guys can understand what's going on. So if we do from 0, 0, 1, 2, 3, right? So we have that, right? So there's going to be a cost associated with the edges, right? I'm saying, so we have let's say we have 2, 3, 5, let's do 8, right? 8, right? So that's how do we represent this graph and adjacency matrix, right? So the same way, guys. So we got 0, 1, 2, 3, 0, 1, 2, 3. Draw that solid. All right. Just quickly do that. So what's next, guys? So we know that pretty much the same logic as the other one. So pretty much right now we have the graph that we have right now, right, is it's an undirected, right? Undirected graph, right? So that means that that both can go this way, it can go that way, right? I'm saying it's bidirectional. So make sure you guys understand that, right? So right now we can go from 0 to 1, right? So we're gonna draw that from 0 to 1, right? Cool. 0, 1, right? So you're probably saying 1, right? Nope. Now we're also gonna take into account the cost, right? So we would put a 2 to associate that to go from 0, right? Because we know this is 2, right? Going to 0 to 1, right? The cost is going to be a cost of 2 units, right? So, and then from 1 to 2, right? And then from we also need to show from 1 to 0, right? 1 to 0. There's a 2 in there, so I put a 2 there as well. So we'll go. So now I'm going a little bit faster, guys. So we can go from 1 to 2. 1 to 2, there's a cost of 3. And then from 2 to 1, right? There's also a cost of 3, all right? And then from 2 to 3, there's a cost of 8. And then from 3 to 2, there's a cost of 3. And then from 3 to 2, there's a cost of tripping 8, guys. All right, cool. So we got that. So let's quickly do it with the adjacency list, guys. So all right, so we got 0, 1, 2, 3. pointing to. So now the nodes, right, it's going to be stored as a pair, guys. So now we're going to have as a key, right, so a pair, right, so we're going to have pair. So pretty much we're going to have so we can go from 0 to 1, right? So the node is a 1, and then the cost, right, is going to be a stash with it, right? So it's going to be a 2, guys, what I'm saying, 2, right? And then yeah, and then also, yeah, that's it. And then yeah, we're done with this one. Then from 1, right, we're gonna add 0 and the cost of 2, right? And then it's gonna be then it has 1 to, it has connection to 2 as well, right? So it would all right, so this is not in we need to show the connection for 2. All right, so we can go from 4 for 1, right? We can go to for 1, right? We can go from 1 to 2, right? So we need to show that, right? So we're gonna have put 2, and then the cost is 3, right? And then yeah, and then yeah, we get that covered. And then for 2, right, we can go to 1, right? So 1 and the cost is 3. So the key, so it's a store as a pair, right? I'm saying, so the key, right, is 1. I'm saying, and the value is the cost of 3, right? I'm saying, so that's what I'm doing right now, guys. So make sure that you guys understand, right? And then 2 can also go to 3, right? Which is just making it clear for you guys. I'm saying can go to for 2, 3, right? So we're gonna store that information. So it's gonna be so 3, and then that's the key, and then the cost is gonna be 8, right? And then that's it, right? And then now for the last one, guys, we're at for 3, right? 3 can only get to getting kind of messy. Just do it real quick, guys. So for 3, right, we can go to 2 for the cost of 8. You know what I'm saying? So you store them like that, and then you're Gucci, guys. You're all set. So we've successfully represented the graph. So pretty much, no, yeah, the rest is zeros for the matrix, right? It goes without saying, guys. So there's zeros, right, to show that they're not connected, and there are no constants. They're not connected. You know what I'm saying? And yeah. So yeah, guys, I want to thank you guys for, pretty much you can see from this, right, that there's a pros and cons to each of them, right? So you can see that for the as you can see matrix, guys. You know what I'm saying, to store those information, right? We have a lot of zeros, right? I'm saying there's a lot of unwanted space that we have already allocating, right? I'm saying, and we do save space by using an adjacency list, guys. What I'm saying, just like but the lookup though is a lot better for in the adjacency matrix than for the adjacency list, guys. So there are some pros and cons to both of them, guys. So if you're not worried about space and you're worried about you could definitely use the adjacency matrix. What I'm saying, so yeah. So I want to thank you guys, man. Hopefully you guys are able to follow everything, and let me know if you guys have any questions, and I'll answer them in the comment section. And yeah, thank you guys for watching, and see you guys in the next one.